Arduino released a new set of boards, the Maker family, and I have a Maker 1010, a board that can connect to Wi-Fi, and via Wi-Fi can connect to Amazon Web Services or services like that. And I just made my first design. It's a low power design fueled by a rechargeable battery, and it connects to the cloud to share its data, and I'm using Amazon Web Services. Where I focused on was battery management. The device will sit somewhere by itself, and I want to know the state of the battery and when I have to recharge it. So what it does is every 15 minutes it will collect its battery status. It will then connect to my Wi-Fi router and send that information to Amazon Web Services. When that's done, it goes to sleep and it waits 15 minutes before waking up and repeating the cycle. And to be able to predict how long the device can run without charging, I have done my measurements. So I have put the device on an amp hour meter, and I learned that every hour it consumes 4.20 milliamp hours. And let's have a look at Amazon Web Services now. My device sends its data to the MQTT battery stats topic, so every time it makes a connection to AWS, we can see our data appearing here in the testbed. That happens every 15 minutes, so we have to wait a little. Our first message arrived, and you can see the data that we're transferring. I'm transferring the battery voltage, the temperature of the battery, the state of charge, 97% charged, the theoretical capacity, and the remaining capacity. But we can't do too much with that data alone, because it's now just sitting on that MQTT topic. But in Amazon Web Services, we can react when we receive a message. And we do that via the Act menu. In the Act menu, we can create a rule that will react on something happening in AWS. In my case, I want to react when I receive my battery stats. The first thing I do in the rule is collect all the data. And I also do a little calculation here. I have made a blog where you can find the details on how this is calculated. But what it returns is how many hours the device can run standalone before you should go and charge it. And now that we have extracted all the intelligence out of the MQTT message, we do two things. The first thing is just a validation check and also something to allow me to act later on, and that is to republish that message together with the additional information that I've calculated here. So this information here will get resubmitted to the MQTT server. We will have a look at that immediately. What happens in parallel is that I'll also send a message to the IoT analytics channel, and there we can report on the data that we have received. But first, let's have a look at that republished message. The name of that message is Analyze. And if I go to my testbed again, I can query for that topic. And you'll see that this topic has more information. It actually has that additional calculation that I made on the original topic. The data that I've added to the payload is the timestamp when I received the message on the Amazon Web Services. Best practice says that your device should send the time, but I haven't configured it for that, so for me it's good enough that I know when the message arrived on the web server. And also that calculated autonomy hours. How long can I live without charging the device? And that's 62 more hours that it can run by its own. I've also created a second rule that reacts on this topic arriving, and when it finds that the autonomy is lower than 24 hours, it will send a mail message. We'll visit that later. Let's first have a look at the data analysis. And that's captured in the same rule. So that was the second activity that I do, is send a message to the analytics channel. Let's have a look. What happens here is that whenever I receive data on that topic, it will push that data to this analytics channel here. And then we will go to AWS Analytics to see what we do with that data. Here we can see the receiving points in AWS Analytics. Let's click on the channel that we have created, and what you see here is the data that has arrived. It's an unsorted set, and as you can see, I didn't have the autonomy hours in my first setup because I first wanted to do the basics, but you can see that the calculated data arrives in my dataset. That dataset can then be used in QuickSight to give you insight into that data. Here is my data set. Let's have a look. You can see all the fields here and the records, and we can then graph that data. What you see here is the percentage charge over time, and you can add more analysis and other chart types. Let's now go back to the MQTT server and configure our mail alert. The rule that I've created for that reacts on the analysis message, and the query will check if the autonomy hours are smaller than 25 hours. If this condition is true, the rule will activate and it will send a message to Amazon's SNS or Simple Notification Service. And it will arrive there on this topic. Let's check the SNS setup. You see the topic here, the battery alert. And there is one subscription on that topic, and that is to send myself an email. So every time that the Arduino connects to the Amazon Web Services and it reports that it has 24 hours or less remaining life cycle, I will receive an email. And here is an example of one of those emails that I received. It's not a pretty one because I chose the raw format, but you see the complete payload here of the message that triggered the warning. You can see here that the autonomy hours are 68 and 68 is not lower than 24, but I cheated. To test the setup, I have put 70 as the maximum number of hours instead of 24. Otherwise, I would have to wait 2 days before this message would trigger. If you're interested in the details and in the source code, check out the blog post that I have linked here. It has the Arduino sketch and an explanation how everything works together. It also links to tutorials for the AWS setup that we're doing in this exercise. You can use this firmware as a base for your own device because it already has the connectivity in it, the ultra low power, it goes to deep sleep for most of the time, and the setup to do measurements. So you can add your own sensors here and your own measurements and send them to AWS along with the battery information. Good luck!